Hello, I'm Chuck Smith, Associate Vice Chancellor at San Jacinto College, where we've been serving the people of East Harris County for 60 years. The college is proud to be a leader among our peers, having been noted as one of the top 10 community colleges in the nation by the Aspen Institute, and also as an Achieving the Dream Leader College of Distinction. I'm standing in front of what will be the Anderson Ball Classroom Building. At 122,000 square feet, we believe it will be the largest mass timber instructional building in the United States when it is completed. The Anderson Ball Building is part of the college's 2015 Capital Improvements Program, half of the proceeds of which were used for new construction and half for renovations and infrastructure improvements. Unfortunately, phasing considerations made it difficult to begin the construction of this building until the final phase of the construction program. That meant that the college had to look for a way to control escalation of costs. The college evaluated mass timber, composite construction, and cast-in-place concrete, all of which could have been used for this building. Ultimately, we chose mass timber due to volatility in steel prices, including the potential for tariffs. As stewards of taxpayer resources, the Board of Trustees was more than willing to build with mass timber once the administration had addressed their concerns about how the material performed in fire and flood events. Lessons learned from other early adopters told us that what really needed to happen was that we needed to put together a team where everyone would work for the benefit of the project. That meant that the owner, the architect, the general contractor all needed to work together, as none of us had been experienced in mass timber other than the material producer. Another benefit of our early planning was that we were able to acquire all of our materials up to 6 months earlier than we might have in a composite construction project. That protected us against price volatility during COVID. As educators, San Jacinto College is all about improving skills and offering an opportunity for a better future. We hope that our mass timber journey will prove to be an inspiration for yours.
This building is just over 122,000 square feet. It consists of classroom space, administration offices, presentation space, and a lobby that connects to the existing Davison building. We researched a multitude of mass timber products that could be provided for this project. We moved forward with the Clt for the deck, glulam for the columns and beams. Controlling your board quantity is really important. This is why in the classrooms you'll find we did 3 rows of columns and beams. This allowed us to reduce the number of plies in our deck and overall reduce the board quantity for the project. The layout of this building took advantage of the use of mass timber. We used single span beams that were aligned with a corridor. This allowed us to position the mechanical rooms at the ends of the classroom bays, routing all the utilities over the classrooms that we didn't have to worry about hitting any beams in the way. In addition, that allowed us to have the corridors fully exposed and really express the mass timber in the building. For mass timber projects, it's important to have your general contractor on board versus a hard bid project. In addition, bringing on board the mass timber manufacturer is important because they will be able to tell you what their capabilities are in their product, the strengths of their product, what it can span, all of those spaces. Plus, is having your MEP and F on board early is beneficial because it allowed us to coordinate fully the building and identify all penetrations and all the structure. And it allowed us to do a quick install from that efforts. The last is having the AHJ on board. We're lucky the city of Pasadena engaged with us as a team player. And so we were allowed to do an alternate means for the combustible materials in the exterior wall of a Type 3 building. We did that by providing fire-treated plywood around the CLT deck.
So we're here in the 2-story lobby space on the 2nd floor. The 2-story lobby space actually connects to the 2-story wing and the 3-story wing. And behind us it is actually the Davison building, which it also is connecting to. We looked at this lobby to showcase mass timber in different ways. So the monumental stair is actually made out of glulam beams that are holding that up with precast steps. while we have the bridge and the ramp also with glue lamps. The ramp itself is actually hung by rods to the beams above. We also look to use Clt Walls as features, and so one of them will have the San Jacinto College logo, while the other one behind us actually has the old Anderson Ball Tech bas-relief panel that was saved from demolition of the two buildings that used to be here. The wood is actually black spruce. It comes from Canada. The manufacturer is Nordique, and the wood is FSC certified as they harvest their own wood from their own forest, which is a great feature to have, and we are very happy to have a sustainability portion there. The columns and the beams here in the lobby are actually double columns and double beams. We did that so that we would have a space to be able to put the lights and the sprinklers, so be able to conceal them there. You can already see some of the penetrations made for the sprinkler heads. We also pulled up the base from the columns so that you would be able to see that and accentuate that. The wood itself is light in color. It comes with a sealer coating from the manufacturer for transportation and protection. Later it will be sanded, and then another sealer will be applied so that for UV fading. The connections here in the lobby are concealed, also knife plate connections. All of these are prefabricated from the manufacturer.
I'm Zach Moffitt, Senior Project Manager with Tellefson Builders. We're the contractor on the San Jacinto College mass timber classroom building. Question that comes up quite often for us is, how does a mass timber schedule compare to that of a traditional steel structure? There's many variables that factor into this, all of which include design, coordination, and procurement of materials. This really falls back to the importance of that early selection of a team and development of coordination. Where we're really seeing the benefit of mass timber is our ability to start our overhead mechanical, electrical, and plumbing systems as soon as those initial CLT panels are set in place. With a steel structure, we're typically having to deal with the detailing phase, as well as waiting on that composite concrete slab to have a usable working surface. In mass timber, those are challenges that we don't really have to deal with, and so you start to see those schedule savings. Another critical component of mass timber construction is early selection of the team, preferably under a collaborative CM at risk model. This includes your architect, your mechanical, electrical, and plumbing subcontractors, contractor, and mass timber fabricator. The benefit of having this partnership early is the owner can more efficiently navigate through the design phase and ultimately get it to fit within his budget. Another aspect to that early coordination is the virtual construction process. Through virtual construction, we're able to assist the design team with design issues as the documents progress. This has also opened up opportunities for prefabrication of MEP systems as well as exterior wall systems, which can ultimately lead to schedule and cost reductions in the long run. Erection tolerances of mass timber are something that have to be accounted for on the front end of a project. So this becomes really important when you're designing edge of slab conditions and especially penetrations. Penetration should be fabricated into the structure to the greatest extent possible in the manufacturer's shop, but it's important to understand where you should and shouldn't have those fabricated. In some instances, you may elect to have some of those penetrations made in the field. A good example of this is if you have a long corridor with exposed wood and pendant fixtures, light fixtures. In this instance, you should probably elect to field core those penetrations because you could end up with a situation where your fixtures aren't in perfect alignment. In this situation, you should account for this in the schedule and plan on coring those penetrations in the field.
As you can see, the Anderson Ball classroom building demonstrates the power of collaboration. Neither the owner, the designer, nor the contractor had prior experience in mass timber. That all came from our supplier. But by working together, each avoiding our own parochial concerns each focused on the best outcome for the project, we've been able to achieve something quite extraordinary. We hope that our journey proves as an inspiration to you on yours. And now, I would like to join the Board of Trustees, the Chancellor, the Administration, our contractor, and our designer in offering our appreciation to the United States Forest Service, Woodworks, and all the members of our team in realizing this project. Thank you.